Good morning, ladies and gentlemen. We have Unit 5B, Lesson 7, solving one-step inequalities. So go ahead and cross out that equations and write inequalities. Our real-world link is about baseball today. So the graph on the right shows the number of home runs that the top hitters on the baseball team hit last season. We have Josh, Mark, Nate, and James. We're going to write an inequality that compares the number of home runs hit by Nate to the number of home runs hit by Josh. So if you take a look, Josh hit about 12 home runs and Nate hit 14. So if we take a look, we know that Nate hit 14 home runs and Josh hit 12. And we know that 14 is greater than 12, so that's how we go through and do that. Take a quick minute to go through question 2 and question 3. Pause the video and do that now. Okay. Now we have to write an inequality that compares the number of home runs that James hit to the number of home runs that Mark hit. Okay. So we see that James hit 19 home runs and Mark hit 24 home runs. So we know that Mark hit a greater number of home runs than James did. So suppose James and Mark go on a hot streak and hit 3 more home runs each. We're going to write that new inequality by adding 3 more to each. So we know that 19 plus 3 is 22, and 24 plus 3 is 27. So if we use that addition property of equality, we added 3 to both sides, and the inequality still stays the same. Okay. Our first target is to solve one-step inequalities by using the properties of equality, like our additions for property of equality, subtraction property of equality, multiplication, addition, all of those properties of equality. To solve an inequality, we use that magical phrase of inverse operations to undo that operation. So for instance, if we're using addition and subtraction, when we add or subtract the same number from each side of an inequality, that inequality remains true. So for instance, if we're adding 4 to each side, we know that's the same. If we're subtracting 3 from each side, we know that's the same. Okay. Take a look at example 1 on the top of the next page. We have x plus 7 is greater than or equal to 10. So in order to undo the addition, we must subtract 7 from each side. So once we did that, we subtracted 7. 7 minus 7 is 0, so we just remain with our x. We've isolated that all by itself. 10 minus 7 is 3. We've simplified it down to x is greater than or equal to 3. Okay, we have a closed-in circle all the way to the right. So why is our circle closed? Because we include 3. Example 2, solve x minus 3 is less than 9. Then graph that solution on the number line. Okay. We add 3 to each side, which is the inverse operation for subtraction of 3. So we end up with x is less than 12. We have an open circle around 12 with an arrow going to the left. The circle is not filled in because we do not include 12. Oh, you can't even see that. That's good. The same goes for multiplication and division. So if I'm solving 5x is less than or equal to 45, we use our inverse operation, which is division. We're going to divide both sides by 5, and we get x is less than or equal to 9. So because x is less than or equal to, it's a closed circle going to the left. Our lovely fractions. So if we're looking at solving x over 8 is greater than 3, that's x divided by 8. So when we're dividing by 8, we need to make sure that we use the inverse operation and multiply by 8. So we have multiplication on 8 on both sides. So when we do that, we're multiplying by 8 over 1, which cancels this out, which brings me to x is greater than 24. Okay, so when it's greater than 24, it's an open circle, arrow going to the right. I'd like you to try the 4U try problems on the top of the next page, A, B, C, and D. And make sure that you please graph those as well. Pause the video and do so now. So when we're looking, and if we're adding 2 to both sides, that means that we have to subtract 2 because that's our inverse operation. So n is less than or equal to 3. So that's a closed circle on 3 with our arrow going to the left. Now remember, when we put the arrow on there, that means that that line goes on forever. So every number to the left of 3 could be a possible solution. So if I have b, y minus 3 is greater than 9, we add 3 to both sides because that's our inverse operation, and we get y is greater than 12. Now it's an open circle around 12 with an arrow going to the right. Greater than goes to the right, less than to the left. It's an open circle because it's not equal to. 12x is less than 72. So that's 12 times x is less than 72. So the opposite of multiplication is division. We're dividing by 12 on both sides. And we have x is less than 6. So it's an open circle around 6 with an arrow going to the left. X divided by 6 is greater than or equal to 7. Okay, so we're going to multiply by 6 on both sides. So I'm going to rewrite so that I can see that what I'm doing. Okay, I'm going to multiply by 6. This cancels out, which just leaves me with x is greater than or equal to 42. So my arrow is closed in. My dot is closed in, and my arrow is going to the right. Our lovely, lovely word problems. Laverne is making bags of party favors for each of the 7 friends attending her birthday party. She does not want to spend more than $42 on party favors. Write and solve an inequality to find the maximum cost for each party favor bag. Okay, let's underline the important information that we have in here. So she has 7 friends attending. She doesn't want to spend any more than $42. More than means that we're going to have an equal to as well. So if she has 7 friends, she wants to spend less than $42, less than or equal to $42 on each bag total. So that's our multiplication inequality. So we're going to divide both sides by 7. So we have C is less than or equal to 42 divided by 7, which is 6. So she can spend at the most, $6 per bag. Okay, on your calendar you need to make sure that you go through and take a look at the notes that Ms. Carlson and I have left for you, and that you make sure that you get all of that done. And behave.